Very good afternoon. My name is Mohd Salim. I'm from Central Pulp and Paper Research Institute. I'm working as scientist in Environmental Management Division. My topic today is statistical validation of makeup water requirement in RCF-based kraft paper mills operating on zero liquid discharge. To start with background, um, um, actually in recent past, with emphasis by regulatory authorities on reduction in freshwater consumption and meeting stringent wastewater discharge quality norms. Some RCA-based paper mills producing kraft paper uh, discontinued their ETP operation and shifted to zero liquid discharge by 100% reuse and recycling of backwater into closed loop just after fiber recovery system using steady cell or mega cell. So this concept of zero liquid discharge without any major technology intervention has been very debatable among the researchers, uh, paper fraternity and regulators. So especially state pollution control boards uh, gave direction to such type of mills to validate their ZLD status by any technical institute. And in this context, we receive many requests from uh, these type of pulp and paper mills uh, to validate their ZLD status, feasibility status validated. So CPPRI worked upon ZLD feasibility, and we did the extensive study in two categories especially. One is validation of ZLD, and second one is uh, the impacts of zero liquid discharge on RCF-based kraft paper mills. So, as I explained, major drivers and benefits of ZLD, that is stringent norms, regulations on effluent discharge quality, increasing cost of effluent treatment, freshwater scarcity, increased environmental awareness. There are some benefits also there: compliance of environmental regulation, freshwater conservation, no treatment cost, high pulp yield. So our recycled fiber-based kraft paper mill operating on ZLD since 2018 was taken up for the study, and this is the profile of the mill. Mill is under C2 category as per CPCB charter, production 120 TPD, and raw material mixed waste paper, 60% Indian OCC, 10% DMC, 30% imported, wet and chemicals, retention rate and filler only, and dry and chemical surface sizing mill is employing surface sizing. Backwater treatment system partially treated through steady cell. Volume of effluent discharge, no discharge operating on ZLD. So this is a profile of the mill. And here our paper fraternity is here. So this is general making, paper making process. Only the size press has been incorporated after pre-dryer section. So this is the practice of recycling or reuse of backwater. All the unit operations like pulp dilution, stock preparation, consistency leveling, etc. are carried out mainly with backwater, and freshwater is reported to be used as makeup water only for cleaning of wire and felt paper machine, sizing, chemical preparation, and boiler feed makeup water. And this is the layout. To the maximum extent, the backwater is being used in closed loop, and the excess backwater goes to equalization tank, and it is treated through steady cell and then recycling. Again, it is being used in low pressure showers or other important sections. Now we collected the sample also. This is characterization of backwater samples. If you see, especially TDS level, it is the buildup is 48,784 in paper machine backwater as well as in combined backwater going to steady cell. So this is a comparatively high figure. If we compare with discharge mill, it is only 2,000 to 3,000 milligram per liter, but in this case 48,000. And the 60% is organic solid, 40% inorganics are there. So calcium, magnesium chloride, inorganics are in the high level. And if you see the conductivity, 13,000. And the cationic demand in backwater is 11,412. So this is the estimation of TDS buildup in backwater, buildup trend until equilibrium. If we see the figure, backwater, the TDS level in backwater getting increased day by day, but after over a period of time, it is constant. It means the generation into the backwater and carryover with the paper sheet is almost in equilibrium at the level of 49.3 gram per liter TDS. Obviously, there are some challenges in maintaining ZLD without major technological intervention or treatment of backwater, that is buildup of TDS, conductivity resulting in scaling, corrosion and deposits, and buildup of suspended solids concentration resulting felt wire blinding and shower nozzle blockages, problem internal sizing due to buildup of anionic trash, buildup of inorganic TDS can affect paper strength properties. So, and the last one, the increased biological activity and slime formation as well as odor problem. And regular maintenance of backwater volume circulated in closed loop. The upper bullets have been addressed by CPPRI, and for scaling corrosion and deposits, will have changed their pipelines as per suggestion by CPPRI. The stainless pipelines they have changed, and for internal sizing, because the anionic trash is very high, so for alternate of internal sizing they have gone for surface sizing actually. But still the industry is facing biological activity, odor problems, lime formation and regular maintenance of backwater into the circulating the closed loop. So the study basically start from here, the RCA based graph operating on zero liquid discharge, statistical validation or estimation of freshwater consumption. If we are able to optimize the fresh makeup water requirement into system, we'll be able to reduce backwater storage capacity as much as possible, so that the slime activity or biological activity can be controlled. So we find out the water losses during paper making, paper machine actually the basic motto of this study to optimize the make water requirement into system. If we are able to find out the water losses during paper making, so we can add the fresh water as makeup water into the same amount into the system circulating in closed loop. So we identified the water losses during paper making, paper machine pre-dry section, post-dry section, steam boiler, water carryover with solid rejects, water carryover with finished paper, domestic loss and some open losses are there. So methodology adopted was that we regularly visit selected ZLD mill, and we collected the different samples at different time intervals and analyzed in CPPRA laboratory, and these samples were collected, waste paper used, paper sheet after press part, paper sheet after pre-dry section, paper sheet after pop reel, paper machine backwater from wire trays, star solution used as size press and solid waste generated. These samples were collected from ZLD mill. Here all samples were analyzed in laboratory, and this is a statistical analysis of data generated. Moisture in waste paper, average, this is average figure 9.21% with standard deviation 0.66%, coefficient of variation 7.19. So, and the dryness paper sheet after press part 48.25%, after pre-dry section 0.77, moisture 0.31, dissolved solids in paper machine backwater 4.88%, around 48,000 milligram per liter, star solution concentration 12.6%, dryness of solid waste generated 29.39%. So along with the standard deviation figures are given, and we developed confidence interval at 95% confidence level, average value plus 2 times standard deviation higher limit, minus 2 times standard deviation lower limit. So we find out the makeup water requirement and lower limit as well as the upper limit of the confidence level. And major relevant data also collected from the mill, like starch consumption, filler consumption. Filler as soapstone mill are using the filler, solid waste generation 4 to 6%, average 5%, steam consumption ton per ton of finished paper 1.75, steam condensate recovery 85%. So basically these are the indicators to evaluate the makeup water requirement in ZLD paper mill. And now on the basis of the data, all the parameters, the distribution of finished paper is essential to find out the exactly at every stage what are the losses basically from the process. If you see the 1 ton of paper, the components of paper are in the slide. Moisture content 0.061 at lower limit, starch carryover 0.055 ton per ton of paper, TDS carryover 0.043 ton per ton of paper, and filler in finished paper 0.03 ton per ton of paper, and the pulp or fiber content is finished paper. This data actually facilitate to find out the exact evaporation loss from each section of the mill. Now this is just an illustration of water loss from paper machine during paper making. If you see the press part outlet, dryness of paper sheet is 48.2% and at the outlet 89.8%. So the difference is evaporation from pre-dry section, and after that it goes to size press. At size press solution is added at 12.6% solids, rest is the water. The water with the solution and the paper sheet from pre-dry section. And if we see the post-dry section outlet dryness, it is 93.2%. The difference gets evaporated from post-dry section. So this is just an illustration how water is getting evaporated from paper machine. Now the detailed calculation are given in our paper. This is a final calculation. The water evaporation from pre-dry section 0.901 ton per ton of finished paper. From post-dry section 0.503 ton per ton of paper, and water carryover with finished paper 0.061 ton, water carryover with solid reject 0.189 ton, steam condensate loss 0.263 ton per ton of paper, and water addition from waste, water loss during paper making, total water loss during paper making at lower confidence limit 1.916 at 95% confidence level, and the same data at the upper limits is 1.54 ton per ton of finished paper. So some water addition from waste paper is there. If you minus the water addition from waste paper, the net water loss, we are able to calculate 1.84 to 1.44. So the water loss is 1.44 to 1.89 ton per ton of paper during the paper making process. This is the percentage share of water loss. Water loss from pre-dry section, mainly the water is getting evaporated from paper machine. 47 plus 26%, around 74% of water getting lost from paper machine, and 14% steam condensate losses, 10% carryover with solid rejects, 3% with the finished paper. Now the conclusion is that this study on estimation of water loss during paper making has established the optimum freshwater consumption range from 1.44 to 1.84% MQ per ton of finished paper as a makeup water in RCA-based craft paper mills operating on zero liquid discharge at 95% confidence level. So the study support regular maintenance of backwater level in closed loop, and the study will facilitate to reduce backwater storage capacity in order to reduce biological activity, slime formation and odor problem. If we give retention time almost 30 minutes, then the odor problem will be controlled. This is basically the preventive control of odor. And the study can also be used as a benchmark to validate the ZLD state of similar category of mills. So thank you.